Hi, welcome to the video training of Elixir, and in this video training we will be discussing basic types. Basic Elixir types are integers, floats, booleans, atoms, strings, lists and tuples. As you can see on the string, we have integer, float, boolean, atom, string, list and tuple. Let's go ahead and explore each of them one by one. Open up IX, that is the interactive mode of Elixir, and type the following expressions. Okay, let's go to command prompt and start our interactive mode. Okay, we are in the interactive mode. Let's start by 1 plus 2. We get 3. Then we have 5 into 5, 25. And then 10 divided by 2 equals 5.0. Notice that 10 divided by 2 returned a float 5.0 instead of an integer 5. This is expected. In Elixir, the operator always returns a float. If you want to do integer division or get the division remainder, you can invoke the div and rem functions. So here we go. If we want to perceive the data type, we can use the div function, that is the division function, and it returns 5 instead of 5.0. Similarly, I can do it without brackets, same result, and let's find the remainder. We have 1. Notice that Elixir allows you to drop the parenthesis when invoking named function. This feature gives a cleaner syntax when writing declarations and control flow constructs. Elixir also supports shortcut notations for entering binary, octal and hexadecimal numbers. So let's try these. Okay, so we have O or 0, B1010, so we got 10. Then we have 0, O 777, we got 511, and then 0 into 1F, we got 31. So we can use binary, octal and hexadecimal numbers as well with shortcut notations. Float numbers require a dot followed by at least one digit and also support E for scientific notation. So if we type in 1.0, we got 1.0, that is float. And then there is a support for E for scientific notation, E10 as well. Floats in Elixir are 64-bit double precision elements. You can invoke the round function to get the closest integer to a given float, or the trunc function to get the integer part of a float. So if I go with round 3.58, I get 4. And if I use the truncate function 3.58, I get 3. Elixir supports true and false as booleans. Okay, if we go with true, we got true. If we go with true, equal, false, we get false. Elixir provides a bunch of predicate functions to check for a value type. For example, the isBoolean /1 function can be used to check if a value is boolean or not. So if we type in is_boolean and we pass the parameter true, it returns true. If we pass in 1, it returns false because the value is not boolean. You can also use is_integer /1 or is float or is number to check respectively if an argument is an integer, a float or either. So for example, I can go with is float and type in 1, but if I type in 1.0, it returns me true. Okay, the next data type is atom. An atom is a constant whose value is its own name. Some other languages call these symbols. They are often useful to enumerate over distinct values, such as apple, orange, watermelon, and atoms are equal if their names are equal. So if I type in, gives me true, and if I type in apple equals orange, I get false. Often they are used to express the state of an operation by using values such as OK and error. The booleans true and false are also atoms. So if I type in true equal equal colon true, I get true. And if I type in is atom true, which is a boolean, it returns me true. And is boolean false, it also gives me true, because the booleans are also atom data type. Elixir allows you to skip the leading colon for the atoms false, true and nil. Finally, Elixir has a construct called aliases, which we will explore later. Aliases start in uppercase and are also atoms. So if I type in is atom and pass in hello, I get true. Let's look at strings. Strings in Elixir are delimited by double quotes and they are encoded in UTF-8 standard. So if I type in hello, I get hello. Note, if you're running on Windows, there is a chance your terminal does not use UTF-8 by default. You can change the encoding of your current session by running chcp 65001 before entering IEX. Elixir also supports string interpolation. So if I type in string equal colon word, I get word. And now if I say hello hash string and double quotes close, I'll get hello word. Okay, I got okay, there is space here. Okay, now we got hello word. Strings can have line breaks in them. You can introduce them using escape sequences. So if I type in hello and then I press enter and I type in world, so I got hello world. Similarly, if I type in hello \n world, I get hello world. So that's how it works. You can print a string using the io.puts /1 function from the io module. So if I say io.puts, it is something similar to system.out.println in Java and echo in PHP and cout in C++ and C. Okay, we have hello world because we added \n and a line break was added here. Notice that the io.puts function returns the atom OK after printing. Strings in Elixir are represented internally by contiguous sequences of bytes known as binaries. So if I type in is binary and pass in the string, it returns me true. We can also get the number of bytes in a string by a function called byte size, byte_size, and pass in the string, give me 5 bytes. Okay, notice that the number of bytes in that string is 6, even though it has 5 graphemes. That's because the grapheme O have 2 dots on top of it that takes 2 bytes to be represented in UTF-8. We can get the actual length of the string based on the number of graphemes by using the string length function. So if I type in string.length and hello, I get 5. The string module contains a bunch of functions that operate on strings as defined in the Unicode standard, such as uppercase. If you want to convert a word into uppercase, you just need to use the upcase function and it will give you the word in uppercase. Now let's look at the concept of anonymous functions. Elixir also provides anonymous functions. Anonymous functions allow us to store and pass executable data or code around as if it was an integer or string. They are delimited by the keywords fn and end. So if I want to define an add function, I can say add equals fn a comma by arrow and a plus b and end. It is something similar to lambda functions in Python, which are defined in one line. So we have defined the function called add. Now we can call this function add dot 1 comma 2. It gives us 3. So basically we are adding these two numbers a plus b and returning the results. Fn is shortcut of function, and a comma b are the parameters being received by this function called add. So if I want to check that if add is a function or not, I can just use the function is underscore function and it returns me true. The arguments are always on the left hand side of arrow function and the code to be executed on the right hand side. The anonymous function is stored in the variable add. Anonymous functions in Elixir are also identified by the number of arguments they receive. We can check if a function is of any given arity by using is underscore function /2. So let's check if add function is expecting exactly 2 arguments. So we can call is function add comma 2. It gives us true. But if I pass in 1, it gives me false because add function expects 2 parameters. Now let's look at linked lists in Elixir. Elixir uses square brackets to specify a list of values. Values can be of any type. So I can define a list here 1 comma 2 comma true and 3. So as you can see, I have integers and I have a boolean value true in my list. So the list is created. I can check the length of a list as well. Gives me syntax error, okay, because I didn't give a space between length and the square brackets. Now I got 3. 2 lists can be concatenated or subtracted using the ++2 and -2 operators respectively. So if I want to concat 2 lists, I can just use the ++ operator 4, 5, 6. I got the final list combining both of these. Similarly, the minus function can be also used to subtract values from the list when subtracted from the other. True, false, and I get 1, 2, 3 true. Because true and false, the first instance of the true and false are deleted from the linked list. List operators never modify the existing list. Concatenating or removing elements from a list returns a new list. We say that Elixir data structures are immutable. One advantage of immutability is that it leads to clearer code. You can freely pass the data around with the guarantee no one will mutate it in the memory, only transform it. The head is the first element of a list and the tail is the remainder of the list. They can be retrieved with the functions ht and tl. Let's assign a list to a variable and retrieve its head and tail. So let's define a list 1, 2, 3. Okay, let's get the head, it's 1, and gets the tail, it's 2, 3. Let's try to get the tail or head of an empty list. it gives us syntax error. Sometimes you will create a list and it will return a value in single quotes. So if I type in 11, 12, 13, I get this string. And if I type in 104, 101, 108, 108 and 111, I'll get hello. When Elixir sees a list of printable ASCII numbers, Elixir will print that as a character list, literally a list of characters. Char lists are quite common when interfacing with existing Erlang code. Whenever you see a value in IEX and you are not quite sure what it is, you can use the I to retrieve information about it. So I can say I hello and I get the full description about it. Term hello, data type bit string, byte type 5, description, this is a string, a UTF encoded binary, it's printed surrounded by double quotes because all UTF encoded. So you get the complete picture basically. If I type in 254, it tells me it is an integer and it tells us the implemented protocols, etc., etc. So you can explore it on your end as well. Keep in mind, single quoted and double quoted representations are not equivalent in Elixir as they are represented by different types. So if I want to compare single quoted hello with double quoted hello, I'll get false. Okay, let's move on to tuples. Elixir uses curly brackets to define tuples. Like lists, tuples can hold any value. So let's define a tuple. Okay, and hello. Okay, tuple is defined. Let me check the tuple size. Sorry, it's curly braces. And I get 2. Tuples store elements contiguously in memory. This means accessing a tuple element by index or getting the tuple size is a fast operation. Indexes start from 0. So if I define a tuple which holds 2 values, OK atom variable and hello string variable, and I want to print the second element which is hello in the string, the tuple, I can just use lm tuple comma 1. And to get the tuple size, there is a function called tuple size. You just pass in the tuple object and it gives you the tuple size. It is also possible to put an element at a particular index in a tuple with put element. So I can use put element tuple object 1 comma word. So this will be added just after the hello string, or it will replace basically the hello string because we already have hello at position 1. Okay. Notice that put element 3 returned a new tuple. The original tuple stored in the tuple variable was not modified. Like lists, tuples are also immutable. Every operation on a tuple returns a new tuple if it never changes the given one. Okay, let's look at the difference between lists or tuples. What is the difference between lists and tuples? Lists are stored in memory as linked lists, meaning that each element in a list holds its value and points to the following element until the end of the list is reached. This means accessing the length of a list is a linear operation. We need to traverse the whole list in order to figure out its size. Similarly, the performance of list concatenation depends on the length of the left-hand list. Okay, this is fast as we only need to traverse 0 to prepend to list. And the below example is slow as we need to traverse list to append 4. Tuples, on the other hand, are stored contiguously in memory. This means getting the tuple size or accessing an element by index is fast. However, updating or adding elements to tuples is expensive because it requires creating a new tuple in memory. That is all for this video training. I hope that you have understood the basic data types available in Elixir and how to use in your application or program. In the next video training of Elixir, we will be looking at basic operations that you can do in Elixir. If you liked this video, don't forget to subscribe to my channel. See you next time with a new topic in Elixir.